these data.
The numbers are increasing.
Okay. So, well, the numbers are increasing here,
Yeah. Oh, it drops off.
but they're not increasing here, right? So does this actual section of the graph look fairly linear?
Mm-hmm.
Does, right? If I tried to do a linear analysis of these relationships, that's this line. So that's the best fit straight line through all of this data. But it's pretty obvious in this graph that there are two distinct regions, one characterized by significant growth, and the other characterized by pretty much flat growth, no growth. Okay? Do you see that?
Mm-hmm.
Okay. Was anybody here 2003 to 2010? No?
I came 2011.
Okay. So my question, and I provided this data to the chancellor, my question was, what changed?
Why the drop off?
What changed? I don't have a good answer for that yet. The best thing I can figure out is that in 2011 we might have increased our admissions requirements, and that decreased our number of students applying. The only thing that doesn't change is why are we flat? In other words,
It's pretty common.
if we just increased our admission standards, we'd expect the overall number to go down. But I'd still expect to see a continuation of some kind of growth. But here, they dropped, and they're just virtually perfectly flat. We had an up year last year. We had more students last year than we've had for a long time. And the chancellor asked the question, well, why did we have an up year? You know, what is going on that year? And from these data, we can't tell. We don't know what's going on. This plot is me attempting to fit the data to a nonlinear line. So this line is a quadratic. So I said, well, it's clear it didn't fit a best fit straight line, right? Linear. So let's see what it does with a quadratic. And so it fits a little better, right? But it's still, we have lots of years that are not inside our 95% confidence interval, meaning that our data does not it's not statistically significant. That's what it means. So anytime you see in the scatter plot a data point outside the 95% confidence interval banding, which is this gray area, it means it's not stat sig. So this didn't help. The next thing I did was look at those individual sections of student head count. So this is 2003 through 2010. We know in 2011 it dropped. This is a pretty darn good fit for our data. We have a data point out here and a data point out here. But the 95% confidence interval banding is fairly narrow there. So our linear, if we did a linear regression, it would explain a lot of this, but it wouldn't explain, for example, this data point. But it looks like we had significant growth. And you can see 58, 59, 63, 66, 69. These, I mean, effectively, these are 300 students a year that we're adding, growing 300 students a year. And it turns out that this result was statistically significant. This is the plot of our flatline area. So our student head count from 2011 through 2016. And so we can see this is effectively zero. What did we say when we have a line or a slope that approaches zero? What does that say about our data? If the slope of the line is zero, there is no relationship between our dependent variable and our independent variable. And so this line is effectively virtually flat. It's flat enough that it turns out that these data are not statistically significant at all. This appears to indicate that we have no growth from over these years. So as years increased, student head count stayed the same. So no growth. So we have two distinct regions, one of growth one of no growth. This is the kind of question that an administrator might ask. And it turns out that our chancellor is a public administrator, right? And many of the employees here are administrators de facto, because that's what we do. In order for us to figure out what's going on with these data, I would have to actually download all of the data on all of the students for all of those years and start looking at variables. Student income, student financial aid, all of the, even race, right? To examine what may have changed, what statistically significant differences are there in students over these years. And maybe there's a smoking gun that will tell us, well, here's the difference. In this year we had these kind of students, and in the flat period, our student demographics shifted perhaps, right? I don't know the answer to that, but I'm going to try and get that data so that we can figure it out. The reason I present these data is to show you two things. First, we plotted the data, and there appear to be two distinct regions. When you see that in longitudinal data or time series data, and we'll talk about that next week, when you see that, you can break your analyses down into years. So I can do a linear analysis over the years where we had growth and another linear analysis over the years that we were flat to see if I can figure out what the relationships are. Oftentimes, if you see patterns in data, by splitting the data apart, you can do your analyses separately and then talk about those distinct time periods. And when I sent this kind of a rough overview of this analysis to the chancellor, I said, we have a significant growth period, and then we have a no growth period. And that's just how I defined them. And I said, if you want me to tell you what's different, I need all of the student data that we have to see if there are any differences in students. And there may not be. That change could have been caused by something that we didn't document. Somebody give me an example of a change that's outside the university that could have caused something like the data that we saw. Growth, sudden drop, flat. Give me an example of something external to the university that would have caused that, or may have caused it.
External to the university.
Mm-hmm. In other words, the issue is not captured in our student data or any data that we have on campus. Can you think of an external event?
I'm thinking having to do something with the economy.
There you go.
Yeah.
That's a great answer. Recession.
Yeah.
Potentially. Now, it didn't line up that we had a recession, but if we time shift that back a couple of years, we might be able to get that drop to occur at the recession. And so there's some argument to be made that perhaps, students, when the recession started, students were already in process. We had great numbers, and the students didn't drop out effectively until a couple of years later after we flushed the queue of the students who were already here, right? The students that were already here, they could have said, I'm here, yeah, we got a recession, but I'm going to finish, right? I'm so close. I'm a year or 2 years away. I'm going to finish. But other students said, whoa, we're in a recession. I'm not even going to start. It turns out that with the Great Recession, that lots of students actually went back to school, right? All of a sudden, MBA programs started to grow as students said, well, I can't find a job, so let me go get a higher education degree. MPA programs grew during that time as students said, the jobs are bleak, now would be a good time for me to go back to school and increase my education. So that doesn't appear to have caused what we're seeing in our student headcount, but it does give you an example of the kind of data circumstances that cause data to change external to anything that we might be able to measure, right? So we'll talk more about time series next week, but I wanted to give you a peek into, this is analysis I did last week. And
It's
so,
interesting that seemingly, they stay right in the 6,200 range. After the
Yeah.
drop.
yeah, that's pretty darn close, isn't it? Here's another thing. I had kind of a breakfast or lunch with the chancellor, and I talked about this data along with the other faculty. And the chancellor said, why did we drop off? What was the cause of this drop, right? Last year, big number. This year, low number. What was the cause of that drop? one of the things that I pointed out to the chancellor is that when we're talking about data like this that is not statistically significant, right? This is virtually flat. We can't say what changed from here to here because the data is not statistically significant. There's no discernible relationship between these data points. So to talk about this drop, to treat this as a real data point and try to figure out what function, what changed, you shouldn't do that when there's no statistical significance, right? Just like I tell you, when you run a regression and you've got a variable and it's not stat sig, you don't talk about it. Whenever you have time series data and you get no statistical significance over the years, you don't talk about any particular year. You can't. There's no comparison that can be made. So even the chancellor fell into the trap of trying to assign value or some causal mechanism to data that's not statistically significant. We just don't do that. If it's not statistically significant, we don't talk about it. We don't make decisions on that, right? The chancellor, now, and what the chancellor actually replied was, we were hoping that this was the beginning of a growth phase, right? So from here, we're at this, then the next year it's up. Maybe we have a growth phase. But when you look at all of these data over this time period, do you see anything that looks like a growth phase? No. So we were hoping that would be, but that's just hope, right? There's nothing here that we can pin a decision on. And these are the kind of things that you'll face or you may face as administrators when somebody dumps a bunch of data in your lap, right? I expect you to be able to understand the data or know how to figure it out. So you might think this class is esoteric. Why do we talk about this? This is the reason why we talk about this. Because sooner or later, you guys are going to be making decisions based on data. And you need to understand when to make a decision and when not to make a decision. Okay, that's it for my spiel for this evening. Does anybody have a thumb drive? And we'll copy your presentations. Go ahead and feel free to copy them. And whoever wants to go first, we're taping this now. Whoever wants to go first can go first. And there is no pressure.
You want to go first? Or
Doesn't matter.
I'll make it.
There's only two of you, so
Yeah.
one's first and one's last.
Yeah.
That makes it easy. You don't want to present, do you, Jing Jing?
No.
Are you sure? You can present your poster from last semester. No? Okay.
Professional paper.
It's starting to look like a phone book. Until you put a lot of work into it. Just remember, read it, check it for grammar. Go to the writing center, make sure that your grammar is appropriate. Uh-oh, did you break it?
What did I do?
No, it's fine.
Oh, here it is.
His singing is almost the same with mine.
Uh-huh, a little bit, yep. The potato
Ah,
on the
look at
couch.
my
Yours was a fat guy, I think.
Yes.
Is it the only view that it has?
What's that? No,
Yeah.
it should, what happens when you click on the presentation screen right here, this little guy right here? What happens when you click on that?
I'll click that one. Oh, I'll see.
That's interesting. Okay, hang on. See if we can debug this.
No,
Go to that.
Oh, there we go.
Yeah, so it turns out it shoved it for some reason onto another desktop.
Okay. Can it zoom? It can't. Doesn't zoom, does it?
Yes, I think we can. Oh, wow, that is really hard to read, isn't it?
Yes.
What size did you size this full?
Yeah, it's I went by the guide.
Okay, good.
Yeah, on my laptop it's not like that.
Okay, let's exit.
Did you do yours on? Oh yeah, you got to do it too. Maybe you can do it. Is that it?
Yeah, I don't know if that.
At 20%. Maybe you can move it up some. Oh,
Yep,
there we
there
go.
you go. Okay, let's put this to full. There it is. So full size. Okay, so yeah, now you can zoom
Okay.
in and around.
That'll work.
Yep. Don't worry about time, I'm not timing you, so let's just go through it.
Okay. Here we go. All right.
Okay.
So of course my research poster again is on the television usage and its relationship with adverse health detriments. And here is a snazzy little picture of something that can symbolically lead to excessive TV usage, being a couch potato basically, watching too much TV. So in introduction to the poster, basically individuals who indulge in excessive TV usage are more likely to have health detriments such as bone and cardiovascular diseases, breast cancer, abnormal behaviors and perception of sex, diabetes, and etc., such as speech and language deficiencies. Also, these health detriments are associated with and are accelerated by the sedentary activity of excessive TV usage. So the more you indulge in excessive TV time, the more likely you are to develop these health detriments. Also, the various factors or the independent variables that will correlate with the activity of excessive TV time. So basically, those factors that lead to excessive TV usage. So what's our main objective? My main objective of this, we want to produce awareness of society spending too much time watching TV, which results in these health detriments. We want to show a relationship between the excessive TV time and the various health detriments. And also we want to ignite a call to action to all public administrators to provide a solution or a plan of action for this issue. So basically we have, we're bringing awareness, producing awareness, then we're going to show the relationship of this awareness, and then we're going to ignite a call to action. So we got awareness, we're going to show the relationship, and then we're going to develop a plan how we're going to fix this issue for public administrators. So here's a description of the variables that are used in the project. Of course, the dependent variable is going to be TV hours.
Nice, is that in green? I can't see it, but is that your DV?
Yeah.
Excellent, good,
Yeah.
good job.
Yeah, DV in green. So yeah, of course, the dependent variable is TV hours, or the amount of TV hours watched per day. And you see the observations or the respondents' frequency is very high numbers, considering our sample sizes, all in the thousands. And then you have the list of independent variables that are related to the dependent variable, or that we're going to analyze to be in relationship to the dependent variable. So these variables, dependent variable and independent variables, was collected through the General Social Survey, GSS, created by NORT, which targets the population of 18 years of older who speak English or Spanish and who live in the U.S. They're collected through face-to-face interviews and also by telephone if necessary. So for the analysis, we have our estimated regression equation with our dependent variable being TV hours, the amount of television time watched per day. We have our constant, and then each independent variable that are in relationship with the dependent variable. So health 1, which is general health of the respondent, is basically our primary independent variable. That's the one that we're going to try to correlate, that have the highest correlation of the in correlation with the dependent variable. And then we have mental health, the age of the respondent, frequency of sex, education, race, and then sexual partners, the monosexual partners. Moving down to the numbers that are listed, we have a dependent variable, and then we have our constant, and then we have the coefficients for each independent variable that are listed with its sign, with its negative or positive in relationship to the dependent variable.
Now, Andrew, let me ask you a question. Are all of those variables that you, that's your predictive equation, correct?
Right, correct.
And are all of the variables that you have in there, are they all stat sig?
Not the partners isn't.
Okay, so make sure you, I mean, I can't tell from here, but make sure that when you discuss that, you indicate that this variable is not statistically significant.
So partners is not stat sig, but I feel like it should be stat sig. That's what you were saying.
Theory suggests.
Yeah,
that it
theory
should be.
suggests.
Yeah.
So that's how I would state it.
Okay, good.
Yeah.
Perfect.
All right. And also, in relationship to the multilinear regression model, some of them, let's see. This is when the main primary independent variable, it becomes not stat sig in the advanced model. So that'd be also something that I'll explain.
Correct. You'd want to try to explain why
Yeah.
it became not stat sig. What variable did you add that made that one not be statistically
Right.
significant?
Gotcha. So moving down to our correlation matrix, we have here our dependent variable listed in the first, and then how it correlates with each independent variable moving down towards the bottom of the scale. Now,
Well, that looks like a scatter plot matrix, actually. Are those scatter plots in those cells?
No, right here.
Yeah.
No,
What-
that's the correlation between the independent variable and each.
So that's a number?
Yeah, that's a number.
Okay.
It's just I guess on the screen it's
Okay, that's
Yeah.
why. Yeah, from back there, it looks like a bunch of dots.
Yeah.
Okay, yeah.
Yeah, I guess on the screen it blurred it out.
Yeah, got it. Okay, now I get it.
A scatter plot. But yeah, so this is the dependent variable, how they correlate with each independent variable moving down towards the scale. These are not in subsequent order of most essential, or what I would feel would be most essential to the least essential. Those are listed in that order in the multivariate linear regression model here. And we have our dependent variable, of course, and then we have the dependent variable here, and then we have what I did was I did 5 different models. I have our base, which is the dependent variable correlated with what I feel is the most significant or the primary.
What theory suggests is the
What
most
theory?
Brad,
Yeah.
Don't say you think.
Yeah, my theory. My
Here
theory
we go.
suggests to be the primary independent variable in relation to the dependent variable. Then which is general health or respondent. And then we're moving into our intermediate phase, which theory suggests to be general health, mental health of the respondent, and also the age of the respondent. As you can see here, they're still stat sig. A little side note, standard errors also are in parentheses, and then the p-values are indicated by the number of stars beside each number listed at the top. So you can see here for the base model, general health has 3 stars, which is correlates with the p-value of 0.001, so on and so forth. As we move across intermediate phase 2, we add in same value, same independent variables, but then we add education into the model. Still the same, all the variables are stat sig, so our model is still good.
So Andrew, I want you to discuss R squared in between the models. So as you're talking about the base model, say the explanatory power or R squared of this model is, and then when you talk about the second model, make sure you cover the R squared, because if R squared is increasing, the explanatory power is increasing, your model is getting more refined. So
Gotcha.
make sure you talk about that.
So how R squared changes.
That's correct. How it changes from your models. I would expect to see it increase
Right.
at every model.
Yep. So good. Okay. So from our base model R squared 0.016 to our intermediate phase is going to increase to 0.032. So increase in our explanatory power. Intermediate phase 2 is increasing 0.077, still increasing. When we get to our phase 3, we're going to add in race to the equation. And this way, this is when all of them are stat sig except for our primary independent variable, which is health 1. This causes the R squared to drop down into 0.034.
Okay.
Um,
Let me look at something. When you added race here, I would have expected to see this
broken down.
broken down by
Okay.
each individual race. So one would be omitted, and you would compare blacks and others, and you would for blacks and others, each would get its own cell. So you would have, instead of having race, you would have blacks in this cell, others in this cell, and you'd speak to which one of those, if they're stat sig, and you would explain how they compare to whites.
And that would adjust my R squared.
Yeah, I mean, this suggests that you didn't do a variable expansion. Did you do a variable expansion on this?
I thought I did, but it's not
So
in the,
it would have to be xi colon
yeah.
and then I dot race, and it appears that you didn't do that, and so that will negatively influence this R squared.
So
Okay.
that's one thing I need to add into my
Yeah, make sure you do and change that to reflect
okay then.
variable expansion.
I think that was one of the when I was saying I had to add in race because race wasn't in my original proposal, so I hadn't expanded it yet.
Right. Okay.
Good. So that shows that race needs to be expanded, of course, which has affected the R squared. So moving into the multilinear regression model, general health has decreased again for its statistically significant value, but the rest of the independent variables still stay stat sig, except for the two that were added, which is sex frequency and partners. Those two did not remain. They didn't seem to be statistically significant, which means it didn't have any p-value, didn't associate any p-value with it.
Well, it has a p-value. It's just not 0.05.
Yeah, it's not
or less.
0.05 or less.
Good. And by the way, when you expand race, you may see these results change.
Yeah. So in our conclusion, the respondents' general health, mental health, age, education, and race are correlated with the TV hours. Of course, we've seen that general health decreases when we added in, or the statistical significance. We lose our statistical significance when we add in race and education to our regression model for our primary independent value of general health. So we lose that statistical significance. In the advanced regression, the general health of respondent, health 1, which is our primary IV, becomes not statistically significant. So this will show that public administrators should implement public awareness programs to reduce the amount of TV watched by society and to show the consequences of indulging in excessive TV time. So for one of the most essential parts of the project, we have our future research. So what we're going to do is we're going to collect data specifically on the correlation between the number of TV hours watched and the number of sex partners, since this was not statistically significant, but theory shows that it should be statistically significant. So how many partners they have had in relationship with the rise or decline in sexually transmitted diseases. So we think more partners, theory shows, more partners you have, more diseases you're likely to have as well. We're also going to collect data on the correlation between the number of TV hours watched and the participation rates in adolescents in youth sports. Theory shows that with the increased time with TV, you have an increased time with being obese, which means you're not going to participate in youth sports or youth activities. So we want to see if we can draw a correlation directly between the number of TV hours watched and the rate of youth activity in sports. So we also want to further analyze the correlation between excessive TV time and reading abilities in youth in school grades K through 12. So theory shows that in younger ages, in adolescence, they're spending more time watching TV, which is impacting their grades as well. They're doing more TV, less homework, basically. And finally, we want to collect and analyze data on the correlation between the number of TV hours watched and the increase or decrease of the respondent's eyesight over a given period of time. So theory shows that the more time you spend watching a screen, the more you're absorbed into the TV, the less likely you are to blink. The less likely you are to blink, the more eye problems you have over time. And here, to wrap it up, we have a little a picture of how society has changed over time. We were skinny with big TVs, then we become bigger with flat screen TVs. So we're getting bigger, TVs are getting smaller. And here's your list of references.
Excellent. Okay, so I have a couple of comments, and I'd like you to write these down.
Okay.
Because these are changes you're going to want to make in your poster.
Gotcha. Okay.
Okay, so the first thing I'd like you to do is find a place and add a graph. And the graph I would suggest that you add is TV hours versus general health, a scatter plot. So a scatter plot of TV hours versus general health. And I think it would be a good idea to include the 95% confidence interval banding like I had on my graph.
Okay.
Okay. And you do that by running a two-way graph, and there's an example of it in that example do file I handed out at the beginning of the semester.
And that was a
The graph will start with the word two-way, T-W-O-W-A-Y. Look for example, and the command lfit-ci is the way you graph those 95% confidence intervals. So lfit-ci. And if you do a help on either one of those, you'll see how to use the command.
So we're gonna do a
Just one
TV
graph.
hours and general health for a scatter plot for that,
Yep, just a scatter plot. That's it.
and then a two-way graph.
No, it's
that
that is your two-way
yeah,
graph.
Yeah, I got you.
So the two-way graph says graph the scatter plot, and then graph the 95% confidence interval banding on the same
yeah.
plot, and that'll give you a plot that looks like the one I just showed you, with student head count. So that's one thing. Add a graph, make it fairly large. You may even want to replace your correlation matrix, for example. The correlation matrix is not visually stimulating. I mean, yeah, it's important and you could explain it, but a graph will draw people in like, whoa, what's that?
Gotcha.
And hopefully what you see is a decrease in general health as a function of TV hours. I would expect you to see that in your graph. And you can talk to that. My next comment is,
Correlation. So I can replace the correlation matrix with the scatter
yeah,
plot.
you could do that.
Okay.
My next comment is, you already make sure you expand race and include that on your tables. I want you to figure out what variable you add, and I suspect it's only one variable, that is making your health variable not stat sig, okay? So try to figure out in your does it just become non-stat sig in your advanced model?
It becomes,
What model does it become non-stat sig in?
I think, intermediate 3.
Okay, so the one right before the
Yeah.
advanced model.
Yeah.
Okay, so intermediate model 3, see if you can figure out what variable is impacting that. And then try to understand the relationship between the variable you added. Why did it take away explanatory power? How is it related to health? Right? What variable did you add in your second intermediate model?
So yeah, it becomes not static sig in intermediate 3, and I added race.
So when you expand race, that may change.
You're probably gonna
It
jump
may
it back up,
change.
yeah.
So your R squared won't change, by the way, but your coefficients on your other variables may change.
Oh, so this is so R squared was actually still increasing here. I couldn't see it before, but yeah, it did. I thought it said 3-4, but it's 8-4. So it
Okay, yeah. So no, what I'm saying is it will still be that. Even when you expand out race, the explanatory power, as we discovered last week, didn't change when we misused race. So that won't change, but your coefficients may change.
Okay.
I'd like to know what's going on there. How would you explain that? You add race, and all of a sudden it isn't health that's important, it's race. What might one reason for that be?
I guess because Knox is expanded, it's combining everything into that one.
Well, no, I don't mean from that perspective. Let's say that you have it expanded correctly and health still became non-stat sig.
Mm-hmm.
Why might that be? What's one explanation? When you add race, health becomes non-stat sig.
Well, I guess it would mean that race isn't. Well, if race is stat
If race stays
sig,
stat sig,
yeah.
could it be that different races have different levels of health, and so the relationship that you thought was really rate or health in your basic regression, when you added race, it turns out that health was spurious. That the real cause is that there are health disparities in races. And so when you added race, it took away health, saying that health may not be the real issue.
That
Maybe
race
related.
may be the real issue.
Yes. So I don't know. That's one option.
Yeah. So in that way, if I did find that out, would it be appropriate to put race as the primary?
No, I don't think so.
It would just be good to explain what's
Yes,
happening.
you would just explain. Here's why I think it had this impact. But obviously, you're going to evaluate this after you expand out race properly and see what happens. And by the way, other students will be watching this presentation, and the reason I'm critiquing you is so that they can, in case they make similar mistakes, people can watch.
I'm glad I could help.
Yeah, you took one for the team there.
I could be the guinea pig. All right.
Okay, so that's it. Does anybody else have any questions for Andrew?
As far as the I'm sorry. I got questions. As far as the layout, is everything good with the layout? As far as the I guess the appearance of it?
Yeah, I think the appearance is okay. The only thing I would change is adding a graph.
Okay.
And I would recommend for those students who actually take the time to watch this video that everybody have a graph. At least one graph. Because graphs can be very visually stimulating. They can draw people in. Whereas tables are kind of boring. So if you can replace it with a graph, your correlation matrix with a graph, I'd recommend that you do it.
Okay.
Other than that, your center picture is funny. It will make people think, okay, what's this about?
Yeah.
Right? Because that's obviously a couch potato watching TV. And so, I think that's very effective, actually. And then, of course, your little comic there with TVs, people light with heavy TVs and now heavy people with light TVs. By the way, people's weight grew and TV screen grew, right? Think about, look at the
bigger
screen.
flat screen
Yeah,
TVs.
but maybe they weigh less than those original
Yeah.
TVs, so maybe it's a weight thing. But I think it's effective, so I thought you did a good job.
Okay.
Okay?
Great.
Very good.
Thank you.
And now it's Brian's turn. By the way, is anything due tonight?
No.
Okay.
Oh, here we go. Take it away, Brian.
Take it away, who?
Brian.
Did you say Frank?
Brian.
Oh, okay. Yeah, I'm gonna have to give Frank a hard time for not showing up tonight.
Yeah. The graduate school will they'll print our posters, right?
So
Symposium.
I think they will. Even if they won't, I will pay to have so I'll refund you whatever you print.
Okay.
So if you take it to Kinko's and get it printed, I think it typically costs $15 to $25 ish.
Okay.
So for a full size poster.
Not too bad.
So if you do that, I'll just pay for it.
Okay.
I don't want you guys out of pocket for that. That's probably gonna move, yep.
Yeah, it's gonna move.
Yeah. So what you have to do is hit. Since we figured that out, let's. Yeah, make sure you say no when it asks you if you want to save this. So where is the? So let's put this on full screen. There we go. So you can move around using these slider bars.
Okay.
So I would just use those.
Okay.
And then if you want to increase the size, just slide this over. And then use the slider bars where you can read it. Okay? Just don't click on anything inside the
Yeah.
PowerPoint or it'll
Yeah,
start
the
dragging
little,
things
the
around.
little arrows at the top too, going above that way.
Okay. All right, so this is my research poster, and it's variables influencing occupational prestige. It's got implications for human resource management and social policy. I had a bit of a hard time trying to come up with some graphics for this topic, so what I found were these little guys hanging out on the ladders climbing up. And what that kind of represents is the level of occupational prestige. Some have perceptions of higher prestige based on their occupation, some have lower. And it could also represent the letter system that they use to, that GSS used to develop this ranking system for respondents. Okay, and then also got a scale here, and this could be, some of the research indicated that occupational prestige, there could be some inequality in that. And it could also balance for some have higher, some have lower prestige. So introduction, the purpose of this research was to examine variables that influence occupational prestige. General Social Survey defines occupational prestige as the respondent's estimation of social standing of occupations. And like I said, it can provide direction for social policy and human resources management. Research literature indicates a link between occupational prestige, job satisfaction, and motivation. And often prestige is used as a socioeconomic indicator. Okay, so objective was to examine determinants of occupational prestige. A lot of the literature was a bit dated when I was doing this study, so I wanted to see, if anything's changed since then and what variables could influence this. Then I got a lit review. This is just some of the selected literature. Most of the ones who had researched this in the past had found they looked at education, gender, race, and there was some that looked at job satisfaction, and they found that it varies among job level. So moving to the center here, in data analysis and results, this is my estimated regression equation. Do I need to blow that up some? Can you see that?
Yeah, you can blow it up if you want a little bit. There you go.
Okay. So estimated regression equation is prestige 80, which is the respondent's level of occupational prestige, plus education, income in constant dollars, job satisfaction. This pie press 80 is the respondent's father's occupational prestige. Literature said that could have an influence. And this one is the mother's occupational prestige. Couldn't find any literature to support this, but I thought it might be interesting since fathers was influenced it to look at the mothers also. And then we have race, sex, and age in the error term. And then the actual equation will be the constant plus the education plus constant income, job satisfaction, of course the fathers, mothers, occupational prestige scores, race, sex, and age.
So Brian, one comment is that you've got your estimated regression equation, but that is actually your regression model. That's
Okay.
not your estimated regression equation. Your estimated equation is the lower one, right?
Okay.
That's your predictive model, or your estimated equation. So switch those around.
Okay.
So the top one is your regression model, the bottom one is your predictive equation or your estimated equation. Either one will work.
Okay.
Okay?
And then included this graphic here is a regression table. What I found was that education was the most statistically significant factor affecting the level of respondents' job prestige. Let's see. And then, of course, we have the income and constant was found to be statistically significant, as well as job satisfaction. The father's occupational prestige score was, which is interesting. If we look at the mother's, it was not statistically significant, and there was no research to back that up. And then with race, I did expand race out. It did drop the first race, which was white, so this is in comparison to whites.
Right?
With 2 being blacks and 3 being other.
And how would you interpret the black and other? Are they both significant? I can't tell from back here.
Blacks were statistically significant with respect to whites.
Okay, and so what does it tell you? What does the coefficient on blacks tell you?
So compared to whites, the blacks have a lower occupational prestige score
By?
by 4.4.
Okay, good.
Yeah.
Good, that's exactly right.
And then, of course, the other race was not statistically significant. Okay. And then this is the regression. I just put it in table form. In parentheses, it's the standard error, and then the t-value with the asterisk designating the p-value.
Okay. By the way, that's the coefficient, correct? Not the, I think you said that's the t-value? Or maybe I misunderstood. That's the regression coefficient, the number, the top number is the regression coefficient, right?
Right, yeah.
Okay.
Yeah,
good.
I'm sorry.
Okay,
Yeah.
just wanted to make sure. So you've got 3 models there, basic, intermediate, and advanced.
Right.
Good. And Andrew, see how he broke out race there?
Yeah, race.
That's exactly what you'll do. You'll
Okay.
just create a different,
Is that the syntax underscore? Was that L race?
I underscore race underscore 2 and 3. Yeah, that probably is the same. And Brian, you could actually just label those instead of calling it I underscore race 2 and 3. Just call it black and call it other,
Okay.
right? Because people aren't going to know what that means. But if you say black and other, then they'll get it. And I would do the same for you, Andrew. Use black and other.
Okay. And then down here at the bottom with the R squared on the
Okay.
basic model is 0.307.
0.30, 30%. Okay, wow.
And then with the intermediate model, it goes to 0.35, so around 35-36%.
Okay,
Wow.
And then with the advanced, it goes up to 37%.
okay,
Okay.
good. Yeah, those are pretty big numbers.
Yeah, so explanatory power is increasing.
Good.
with each model.
And any surprises? Any things that were stat sig that became non-stat sig? Any reason? From here, it looks like all of your most important variables were stat sig and remain stat sig.
Right. Yeah, they were. The only thing I thought that stood out to me was interesting, of course, was the father's occupational.
Okay.
And then the mother's, how one was stat sig, but the other one wasn't.
Right. So let me ask you a question, and this is just for my own edification.
Okay.
It looks like the age, gender variables, are those not stat sig, or are they stat sig in your advanced model? All of the variables under race, gender, age, and I don't know what that third one is. Oh, that's your constant.
Yeah.
So is race or is gender and age stat sig?
They were not.
They're not. Neither
They're not.
one of them are stat sig. Okay. That's interesting.
Mhm.
I'm not sure that makes a lot of sense to me. I would expect that SEI is that the older you are, the more likely you are to have a higher SEI as you climb the corporate ladder or whatever, right? You start off life at 18 working at Burger King, and you decide you want to go back to school, you get your real first job, right? So I would expect that to change as a function of age, and you're not seeing that change. That's curious.
I may need to go back and explore that.
Well, yeah, but
There was some literature that said, it could influence it, but
okay. And gender, I'm a little surprised that's not stat sig, because I would affect, if there is a glass ceiling between males and females, we know there's a pay disparity. If there is a glass ceiling, I would expect men to have, on average, higher SEIs than women. So, when you talk about age, figure out what's going on with both those variables. I mean, one argument could be that there really is no glass ceiling for women, or it's gone away, and that women's SEIs and men's are comparable. That's one potential explanation. I don't have a good one for age, though. I mean, age just seems like it ought to be significant, and it's not, so I don't know why. Okay, good, go on.
And then we have the methods section, using data from the 2010 General Social Survey. Used to sample 2,444 adults ages 18 or older. And they collected the data using interviews conducted in person and by telephone.
Okay.
And then conclusions, education, income, job satisfaction, race, and father's occupational prestige score were all positively correlated with the individual's level of occupational prestige. Education seemed to be the largest influence on the respondents' level of job prestige. Understanding these relationships can help human resources develop management strategies and provide guidance for social policies. And I put further research to determine why education is such a strong predictor of occupational prestige, and why a father's level of prestige is significant but not the mother's.
Okay, you don't talk about race there, do you?
No.
I would talk about race. I would mention that blacks, on average, have a lower SEI than whites. And was the other category stat sig or not?
It wasn't.
It wasn't, okay. Okay. And in general, you're not going to talk about your references unless the
Right.
reviewer
Yeah.
asks you about them, and then you'd be prepared to mention why those are important. And Andrew, for you as well, list only your most important references, right? List the ones that you can talk to most easily. Okay, so Brian, for you, some generic comments. First, you've got two relatively large graphics there. I would replace that with one and find a more interesting graphic.
Okay.
My recommendation would be to go to Google, and in quotes type "climbing the social ladder," right? Put it in quotes. Climbing the social ladder in quotes. Have Google search that exact phrase, and then click on the images tab, and look
Right.
at all the images that may come up. You may find, I mean, you may find something quite interesting. The thing that's going to stand out is if like you have a ladder with like a garbage man at the bottom or a Taco Bell worker, and at the top maybe I don't know, an engineer or a doctor or something,
Okay.
or caricatures of those. Find something that's going to pull people in.
Okay.
Your two graphics are very, very large. I would make them smaller and make them a single graphic,
Okay.
and try to find something that's humorous or shocking or something to draw somebody in,
Right.
because that's what's going to make them look at your. Honestly, I believe the reason our student won last semester is because her graphic was very compelling. I mean, she had a great poster, but her graphic really pulled people in. I heard people mention, "Oh, what's that?" Right, and they'd come over and look at it. The next step is replace your regression table with a graphic.
Okay.
And I want you to figure out what graphic is most visually stimulating, which one of your graphics is most visually stimulating, and then I'd like you to include it there. One thing I like about your poster is that it's very clean, lots of white space. When you go to print it, you're going to want to make sure that you can read that. So you have lots of room to expand fonts if you need to. So explore that.
Okay.
But it looks very clean, very uncluttered, nice. It really stands out that way. So just keep in mind you may need to increase font sizes to actually be able to see it. And you've got the guidelines for font sizes, right? Make sure you,
Okay.
what did they say? Did they say 72? Do you remember the guide that Dr. Booman handed out?
Title was like 96.
Yeah, so make sure you meet those requirements. And maybe you do, I don't know.
Yeah,
but
I
just
used that
make-
guide that was in the PowerPoint.
Okay, good.
But for that font, I thought it was a little small, but that's what it said.
Yeah.
Okay, so just look at
I was
that.
battling with that too.
Yeah.
I wanted to make it bigger, but I was like,
But you can. It doesn't have to be a set size. I mean, this is all about balance. And so you have lots of white space, which looks nice, but to me, your text looks like it might be small. So you have room to play with that a little bit to get balance that you think is aesthetically pleasing. It isn't about rules, right? Because it's just about how we perceive this picture. And I think both of you did a very good job. I've made some recommendations, but they are relatively minor. So I look forward to you guys defending these and hopefully somebody from our class winning. Not that I'm competitive or anything. Okay, does any other student have any other questions for Brian?
I found some pictures for you.
Oh, did you?
There you go.
Just
See,
a phone.
and if I'd had my computer, I would have been searching for pictures for you as well, because there's a lot you can do with that.
Yeah, I started to put up some like dog collars for white and blue collar. And
Yeah, yeah. Yeah, no, that'd probably go over people's heads. Like,
Yeah.
what? But yeah, Andrew, send him a link if you can, and get something creative. So nicely done. Does anybody have any questions about where we're headed or what we're doing? I think I put on Blackboard that by now you guys, the light bulb should have come on, that these analyses that you're doing should make sense. Has the light bulb come on
Yeah,
for both
I'm
of
good.
you? I mean, do you get what it
Yeah.
is that we're doing?
Yeah.
Good.
Yeah, I'm good. I just
Good.
need to expand that race.
Yep, yep. Yeah, so as long as you understand, I think you guys will be okay. If you are lost at this point, or if any student online is lost, you shouldn't be at this point. And like I posted on Blackboard, if you have issues that are important or urgent, just call my cell phone number, and I posted myself. It can be weekends, nights, it doesn't matter. From this point forward, I want everybody in the class to be getting their work done, not struggling over basic concepts. So if you're struggling, or if anybody watching this is struggling, call me, okay? Don't struggle, because there's a lot to do towards the end of this semester. One other thing, there won't be any more exams, so you don't have to worry about exams in class anymore. I still want you to read the material so we can talk about it, but I'm not gonna quiz you on it, okay? So don't be stressed about that. Okay, any other questions, gentlemen?
And no more stat assignments.
That's right. I used to have a state assignment 6, but what I found is that students were just dying at the end of the semester, and so I deleted it.
Yeah, good.
Yeah. All right, no other questions. You guys are free to go.
Thanks, sir.
Video helper, you can stop recording. Thank you so much.
say like for the independent variable that have partners, that's not stat C, and